So just to start, guys, thank you so much for being here. We are going to talk about how we did some test modernization in some Jakarta projects, and we are trying to do for most of the projects from Jakarta. It takes a lot of time. We will share the experience we are applying through basically NoSQL and Jakarta data. My name is Elias. You guys can follow me on Twitter, LinkedIn, GitHub. Most of the projects I do, there's a lot of projects on GitHub as well. I'm a Brazilian guy. I live in the Netherlands right now. I'm also an Oracle Ace for Java and DevOps, and I'm also a Java Magazine editor for the Netherlands. So if you guys want to write some articles for Java Magazine Netherlands, ping me. I will be super happy to have your article there. So you can even write in English because half of the magazines, almost the whole magazine is in English instead of Dutch, so it will be super cool.
Yeah, that's nice. My name is Otavio Santana. I'm here to, of course, explore the open source world. But basically here, we talk about the migration and evaluation of tests that any organization might have any kind of situation like that, right? So increase the software quality, increase the tools, each tools which I use, how to use documentation to increase the quality, especially in the test aspect, and how to keep everything working with test quality and, of course, increase the reliability of the software. So the main point here is, of course, talk about those open source projects, but also explain, okay, how can you learn from those open source projects and put in your organization this way, this strategy, okay?
Yeah, we are going to show you guys some slides, of course. Some slides might contain code, but instead of reading the code on the slides, I will show through the IDE. And I will run the code in the IDE just to prove it's working or not, and just for you guys to see, okay, it's this way we are implementing, okay? I will be seated because I will show some code. Otavio will be standing, but yeah, you guys can see us and can hear us, okay?
And if you have any questions during the session, please let us know. So before start, who is familiar with Jakarta specifications? Raise your hand. Who knows about Jakarta NoSQL? A little bit. So the idea of this specification is to make easier to work with Java and NoSQL database. So we're going to have several APIs, several annotations, and based on that annotation, we are capable to use several NoSQL database using those annotations. So for example, here, we are using the book records with a couple annotation, and based on that annotation, I can, using this provider, be compatible with OrientDB, Couchbase, MongoDB, and MongoDB. As you can see here, mostly of those NoSQL database are document types, right? So the idea is one single API to many NoSQL database providers, where what I'm doing here is basically have one API to NoSQL database type. Okay, so this one here is document, but we do have white column, we do have with key value and graph database. And move on, Jakarta data. Basically, the idea is we talk a lot around patterns in the application side. So we know singleton, we know decorator, we know strategy, and so on. But how about data? Each patterns we are capable to use and explore using enterprise architecture. The main goal of the specification is to create and engage those patterns with enterprise Java. So for example here, next slide please. Yeah. We are using Explore one pattern super popular that is repository from DDD by Eric Evans. So as you can see here, we do have the product repository that extends pageable repository. So the idea is, based on this, I don't care about the implementation. So each provider might have a different NoSQL database or SQL database or even anything else targets. So the idea is to define these patterns. I'm capable to be, for example, on this feature, more domain-oriented, okay? That's the whole idea of those specifications. Jakarta NoSQL, make easier Java NoSQL data to explore more around persistence patterns. So right now, let's talk about what's going on with the project, especially because we are talking about 3 and 4 years old projects. So Elias, go ahead.
So basically what we did have on this project, a legacy code, of course, since 2017. So yeah, and all the code is legacy as soon as you finish it, right? But yeah, we are talking about some years of legacy codes. No structured or defined development process, and development process also include testing, for sure, right? Because we develop, we test as well. And it was a several proof of concepts in different ways, a lot of POCs around the projects. So no, let's say, it's not in exactly that way, but non-structured. So we had a lot of projects not with the same structure and everything. That's why we are trying to get one of these subjects, which is testing, and try to create this process and the consistency across all the projects.
And also, we do have several companies with different times. So we do have, for example, Oracle with some thoughts, IBM, Red Hat. So like any organization, right? People come in, people come out, onboarding, offboarding, and so on.
And how we started this test modernization. So we have 6 steps applied in the projects. You guys can have more, can have less. Those are the steps we are going to talk about and show you code. So the first thing, we created a test guideline. It's normal to have a contribution guideline where you guys can know how you can contribute, how you can do the pull requests, you can develop the code. But testing is also important. And we created a separated testing guideline for that. Super easy one, but showing how we can create tests. We will deep dive on that. Modern test libraries, it's a common thing. It's good if you guys are creating tests with the libraries you guys have, but you guys might not using the, let's say, or either correct tools or the most modern one or proper for the job. So we are trying to apply this as well. We are trying to apply as much as possible a data-driven approach for testing. We're going to discuss this. Extensive assertions, because normally the testing framework you are using is not providing that much assertions. Coverage extension, that is super nice because we need to look at the projects. And of course, as much as coverage as possible, because those specifications will be used by a lot of different companies and people. So we want to make sure it's super tested and the coverage is high. And in the end, as we are talking about mainly about NoSQL and we have a lot of different databases, we are talking about how we can use containers for testing, because it's a super normal thing nowadays, and we added this in the projects. Cool? So first thing, and guys, if you have any questions in each main topic, we will just stop a little bit and ask you guys if you have some questions, okay? So testing guidelines. Why is it important to have a test guideline?
Especially because documentation, right? I mean, we need to make sure that everybody that's coming is capable to understand what is going on and also to create new tests. I mean, if everybody goes to the project and define their own style to define tests, the long-term support, it's become a nightmare, trust me. I mean, I do that in the open source world, I do that in finance areas as well. So if you don't have any standards and any procedure, it's hard and tough to maintain this kind of code.
We define a test guideline super easy to understand and short. Talking about the tools to use, the naming conventions for testing, a specific creation approach, and the coverage extension. So what we did, I will show here the one, it's my local, but it's from NoSQL. It's super easy one, but what we are saying here for the contributors, use JUnit 5 because it's a modern test tool right now. JUnit is an awesome tool right now. Use AssertJ as assertion library because it provides a lot of benefits. Prefer using AssertJ over the JUnit 5 assertions because of like AssertJ is more powerful in this sense. And the naming conventions. So everything, of course, is normal. You guys know every class that is a test class should end with test, right? We can have those different integrations, etc., but test should be there, written there. The test method names. It's better to understand when you start a sentence with should and the sentence. So I should do this, 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 and that in the method. For example, should create pageable, and the test should do that. We have another for corner case, and you need to express that. But at some point, the test name will be super long, and it's difficult to read. So we are saying use this display name for JUnit 5 so you can put something you can really read, and it will be understandable in your results. If you go to the CI/CD and see the issues, will be this display. This name will be displayed, of course, with all the stack trace. And for the creation part, we are going to show through code as well. This part prefer soft assertions versus instead of hard assertions, and I'll explain later what is the difference. Okay.
And one important thing here, if you don't mind to show the repository, everything as a code, that's included the documentation itself. This one here is like stock at the root of the project. So this way, once I clone the project repository, I do have the access to everything, including the documentation itself. So my recommendation is put everything close to the code. That includes the aspect, the recommendation, the engine. When I try to put away, like a week, something like that, for some reason, we forget that, and everything that you might forget, we're gonna forget. So please do it close to the code. Everything as a code, including documentation, recommendation, and things like that.
The next part is the modern tools. And we explained basically all the modern tools we are using by each step. But for now, like the most modern, tool or library used for testing should be the testing library, right? The unit test library. We have different ones in the market, but the best one, by my experience, and the projects I'm working on right nowadays is JUnit 5. It was super well developed with a lot of contributions at the beginning. The support for the community is awesome. The guys are super open to any other things, and they are keeping they are continue creating new features for that, which is awesome. They are not stuck in the time, so they are evolving the tool. All the tests that we are going to show, we use JUnit 5, so I just explained a few things. And when we starting the assertion part and coverage, etc., you can see the whole perspective. But from JUnit 5, the best things we can use is the test description you guys saw in the test guideline, the description, the environment condition. I can run some tests based on the environment conditions. By environment conditions, you guys can think about like real environments or any kind of environment that you guys, okay, I must run this test, like, I don't know, integration test, only if it's that environment. So that test will run only in that conditional circumstance.
For example, we are talking about data persistence layer, right? So we can mock something, but you must do the whole integration point. But as you're familiar with the pyramid, it's more expensive. So we don't need to run the whole time. So you can enable that to make it easier and cheap. Remember, if you put everything to run all the time, the developer will not run. Trust me, if they don't run, they're not able to write more. If they don't write more, sometimes it's gonna break and nobody will even notice about this issue.
And the last thing about JUnit 5, we love this feature is data-driven testing, and they had implemented in different ways. The different ways is more than 3. They have 6 already. So value source, method source, and argument source. And we are going to show as well you guys some code related to this one. Okay? So far, questions? Everything's good? Nice. So now we are starting to see some code. So talking about the data-driven approach. Just to tell you what is data-driven, if you guys don't know, is the way in testing that I can have the same piece of code when you guys can figure out that the data is the only thing that changes. The whole code is the same, but the data is changing, but you have the same result. Instead of creating multiple test methods, we can use this data-driven approach to tell the code of the feature, okay, these are the data, this is the code, don't change the code, only iterate over and over all the data I have. This is the code part, so you guys for later, when you access this slide, you guys have access to the explanation and the class itself, and we are going to see this value writer, and I just need to do this to copy to easily find it, and here. So this is the NoSQL project. What we are doing here, and you can see a lot of good things. So from JUnit, I'm telling here it's a parameterized test, so it's a data-driven test. Has some parameters for that, and I can even play with this output, and we show the output. I have the display name, so instead of try to understand should verify compatibility, I have this correctly, should be able to verify the test compatibility. And this is the feature from JUnit, and super easy. I have a notation value source, and I'm saying I have a list of classes, an array of classes, and the classes that are compatible with the value writer I have here are enum, optional, and temporal. And look, the test is AssertJet value writer dot test. The supported class is true. This value writer dot test is returning for me, okay, if I support the no, it's true. If I don't support the no, it's false. So I have the positive scenarios here. And I don't need to create 3 different test methods. I just have one test method with different data in this term, the class. Of course, this value source has a lot of different parameters here. Most of them, if it's not classes, are primitives, like booleans, bytes, char, doubles, etc. These might not fix or be used in different contexts of data, but there's different features here that we'll talk that can be applied. Just make sure you guys can see. I will just run. Perfect. Unfortunately, I cannot zoom, but I can go to what I didn't do, the presentation mode. And let me run this again so we can see a little bit bigger. This superhuman readable way. So my test, it should be able to verify the test compatibility and must be compatible with the enum, the optional, and the temporal. If I would support one more class, my test need only to have, I don't know, string.class. It won't work, of course, but I just need to add one more item in my list, and that's it. I have one more test. I will run, this will fail for sure, because it's not compatible. You can see, okay, string is not compatible.
And as you can see, there is a decoupling between my tests and my data. So in terms of the architecture, I can try to avoid any kind of issues. Okay, let's freeze the code there, the data there, something like that. This way, no. My test should not notice what's going on. So imagine right now that you have a person entity, product entity. You can inject this parameter and work with that.
Now I have a different data-driven approach. That one was with class and primitives. If I need to use objects or any other thing, I have this method source. The method source, I need to create a different method that holds the data for me. And JUnit will do this connection. So in this test, I have the value writer here, and I need to see if I can write based on temporal classes, like local date, date, etc., that extends temporal class. And you can see that I have this method source, I have the method name here, and I have a parameter which is the temporal. How I can connect this thing? Normally I have a method. For JUnit, it's a string of arguments, and I have a string with arguments, and each argument is what I need to pass through that method. So I have the local date time, which is a temporal. I have local date, which is a temporal, year, which is a temporal, etc. And if I have one more class which extends temporal, I just need to add one more line, and I have one more test. In this way, I just duplicating here, but you guys understand, right? Any new item that I need, I don't need to create more methods. Just add one entry, and that's it.
Yeah, there's another one I'm not sure if I'm going to show today. It is about classes. So you can create a class to create this parameter for you.
Yeah.
So imagine right now that we want to receive data from web service, database, or things like that. And you don't care about this in your test scenario. You're able to put this annotation, put the class, and the class will inject everything that it needs, and then inject that information from there. So for your test, it's just an object. From that class, it will do everything that you need, like web service, database, and so on.
Just prove that this works as well. Let's run it. And let's see. Perfect. So should we convert temporal? And I have all the values for the temporal because I'm using that class .now to get the time for now for the temporal, and just listing here for different ones, for year, for local date time, etc. Cool. Questions so far?
Yeah, so maybe one
Yeah.
remark is that, yeah, but the method source is a string, of course, not type say. The value source is plus literals. There's just one other use case for having a method literal Java language as well. So I'm trying to get Brian and the other Java guys to do Java and method literals Java.
Okay.
They're a bit resistant against the idea, but this would be one more good use case.
Yeah, so have here, yeah. So continue with this. We have the extensive assertions, and for that we use the AssertJ library, which is a assertion library. JUnit normally has, if I'm not mistaken, like 4 or 5 assertions only. Assert equals, assert true, assert false, assert not equals, and I've
Null, assert not null.
yeah, not no. So it's, but imagine if you have a complex object or a string list or a string or a list or anything, a collection in general, you need to test that. It's hell to do it with JUnit because they don't provide a correct method, let's say. And you need to write more code to validate that. And writing more code, it's more maintenance. AssertJ has methods for everything, for the string, for temporals, for everything. So it's super easy. But we would like to focus on 2 different things. The first one are the soft assertions. And I will go to this class and explain to you what is the difference about...
While you're loading here, one thing that I enjoy about AssertJ is if I don't remember anything, the API is fluent. So I don't need to do a control space or the command space, and they show for me the options that I do have. For example, if I receive a list, it's gonna show me the options to do a validation with the list, like it's empty, it's not empty, and things like that. If it is in a map, I can validate by keys, I can validate by values, I can validate for anything like related to the map. Optionals, and so on. So with this Fluent API, I can explore if without reads extensible documentation, because the Fluent got me the option, the flavor that I do have to the specific type.
So what I'm going to do, this test is for the key value databases. Easy one. I will just comment to show you the differences. So I have here the key value, Diana and Hunt, okay, for the key value database. And I'm just doing some things here. And I expect that the key after this whole transformation behind the scenes is Diana and the value is Hunt. But what I will do, I will just add more text here in the validations to make it fail, okay? This will fail because it will not be Diana. And I will run. And of course, JUnit will say to me, okay, we have a problem. And the problem is the key is equal. So expected Diana and now it's Diana, okay? I will fix that. And I will run again. This is the normal thing we do, right, when we write tests. But now I have another error. Hunt, it's Hunt. So I'm here, fix. Normally the fixes take more time than this, right? And my point here is hard assertion. It stops at the first failure. And you need to keep executing the class until you fix everything. It's super time consuming. What is the difference compared to soft assertions? So for soft assertions, I need to group them, and I'm telling through this assert softly. Softly assert that this entry key is equal to Diana, and softly assert that the entry dot value is Hunt. I will make it fail as well. And when I run, in the end, it will show me you have 2 failures. It's executing all the tests, all the assertions, and after that it's showing to you, those are the issues. And it's good because normally we test complex objects with a lot of attributes. And we can see, group it, okay, which ones failed, which ones are okay, and we can just be super assertive and do one fix maybe, instead of like several fixes all the time running over and over again.
It is super worth, especially when talk about some tests that need to write a container, application server, database, and things like that, right? So I can do the whole validation and aggregate as result.
Yeah, so this is good to get a complete overview of which tests worked and which failed. But sometimes, let's say we have so many tests that it takes so long to get the first result, right, that the failure has occurred. So it's maybe good in most of the cases, but in some cases you might find the hard assertions.
Yeah, there's no way to escape the trade-off, right?
Yeah. Yeah.
The trade-off is still there in the good sense of the soft architecture, soft design is still valid. We use the software assertion in some things, but it's not silver bullet. So hope everybody understand that. So it's a good option, but not the unique option. Elias?
The next thing using AssertJ is that normally we must, of course, test the exceptions, right? And it's a super fluent way I can easily test that. So when we have some specific methods for the most common exceptions, in this case, it's super easy to understand. Assert that illegal argument exception is thrown by this condition that will throw the assertion, and I need to guarantee that the message is, the condition is da-da-da. So, super easy, right? I need to tell, okay, this will throw an illegal argument exception, this is the piece of code that will throw it, and if I want, I can even check the message. If I run it, it's perfect. Done. But this, what is the case if you guys have a custom exception? It's easy as well. So in this case, when I'm doing this key value prepared statement, I have a specific here, query exception. That is a custom exception from NoSQL. So when I have it, I'm telling here, assert that throw, and the piece of code that will throw that is the instance of this exception, and it has the message that. Super easy to test exceptions, only one line basically, so I'm just like creating different like lines just to see like beautifully like in the code. But it's one line of code, you can test exceptions, at any kind of exceptions, any type. Questions? No?
Everybody's sleeping.
So this is the most nice thing that I love it to use, is the coverage extension. So we do a lot of coverage, right? Because we have like Sonar and other tools that has internal tools to show the coverage. But there is a trick part on that. We humans, we cannot see all possibilities of testing. And even though I can have like 100% of coverage, I might not thinking about something specifically that my customer will do, or the library that using our libraries will do, etc. So that's why pass partially this responsibility for tools. And we have a super nice tool in Java, called PyTest, P-I-T. PyTest is a mutation test library. And what is the goal of this mutation test library? To do all the wrong things in your code. To mutate your code, basically. If the code says, okay, you have a condition that must be equals, it will change your code to not equals, and we see if like the test is still running or not. And that's fine, because it's a super valid test, right? It will happen. Someone will add a parameter with the value that is not equals, and you need to test that. Sometimes you can see, of course, easy things like this we will see, but complex algorithms we are developing, we won't see that. Let me show And this is super nice because the coverage for the Jakarta projects are high, but as soon as we apply it, the PyTest, we could see some gaps. And this is awesome because, okay, I was not thinking about that. I won't show internally, but we have a profile here in the project, you can see later. I can run mvn clean test compile, and I have this PyTest profile. There's some configurations there. I will skip that. It will run a little bit, and it's error. Why it's error? Let me run in the, sorry. Let me change the project because I was doing some nice things in this project. That's why it's not working. But here we work. So I will run this mutation test. It will do a lot of things, so super verbose, but it's actually changing my whole code based on certain conditions. This will generate a report on my target, and this is the scenario. So my coverage basically is high, but I have these two new items, mutation coverage and test strength. When I look deeply on that, there's one streamable that has no, but this keyset cursor. Yeah, let's get this keyset cursor. And I can see the code here. I can see the exercise methods. You can see this number 2 on the left side. PyTest tried to mutate my code on this line. And it shows here, we tried to negate conditional. And it was killed because I have a test for that. And can you see it's equals? And try to apply it not equals. And try to see if the test will fail or not. So the tests were not failing because we have tests for that. But in some points, and you can see here, like negate condition, replace return, etc. If I, let me get any, just to show you it failing. Yep. So limit test. And I will do not good thing here, but I will just comment some tests, just to show you how the two can work. So I will run it again. Of course, we will decrease the coverage, but I would like to show you a different thing, not the coverage itself. But I will refresh, and I need to go back to the limit, right? And the limit, yeah, decrease it. And I can see here, for example, there's one verification that failed through the mutation test because there's a condition equals or greater to, right? And it failed because it's, okay, change conditional boundary survived, replacing long subtraction with additional killed, and negate conditional killed. So killed means it's not right. And survived is cool, you have a test for that. So I need to implement tests for replace long subtractions and negate condition. Cool? And things we cannot like just look at the code, okay, testing it. But there are more edge cases we can add. Questions? Oops. The last thing, and you're almost on time, right? And Otavio can explain a little bit as well, that's containers for test. And what we are trying to do here is we do have in JNoSQL a project to test with all the JNoSQL databases. And in order to test with JNoSQL database, I need to have the database itself. And nowadays, you guys have a container. But you guys need to manage the life cycle of that container. You guys need to start the container, make it living there until you finish the test, and you guys need to go there and stop the container, right? It's a manual process, boring. It's not automated, and we need our test to be super automated. That's why we are using test containers, which will do exactly like this life cycle. If I use test containers before I can run the test, we'll deploy this container, we instantiate this container, starting it, we'll make it there, persistent, until my test ends. When my test ends, test containers automatically will go there and stop the container. And we'll do everything. We'll download the container, the latest updates, and everything.
Yes, and one discussion point here is exactly because as NoSQL database, we are testing over 25 different NoSQL database, so it's a huge amount. And of course, this container makes the life cycle easier, especially if you decide to go to CI, CD, or things like that.
So just to show you how it works in this project, we have here a document database, and for TestContainer, it's super easy. Basically, I have here a generic container, and I'm telling, okay, get the Mongo as latest, expose this port, waiting for it will be ready, and we have more things here just to configure additional things on MongoDB, okay? But basically it's this.
Yes, it's a singleton. As you can see, we're using enum, like effective Java said, and the idea is to avoid to every task create a new container. There are database that's super cheaper to create, there are others not so cheap to create. The idea was to reduce the number of time to run the whole test.
And what I want to show to you, because of that I have Docker here, I will run the test, and you will see a container being spin up, and scale up and scale down. So I will run the whole test scenario here that is using test containers, and you can see test containers, MongoDB, and test containers, this one with the MongoDB, for a few seconds later will be removed. It's still running, or Mongo latest is still here. Now exited.
Gone. Yes.
I can force it as soon as the test really finish to close it, but I can send the responsibility to test container. So what we did here, total automated process for any database that has a Docker container. I can use test containers for that.
And another point is an annotation to enable or disable, because this one here is integration test. It requires a database instance. So what we did here was to, okay, let's put that condition. If it is a variable running, run the test. Otherwise, don't run the test.
Cool. Questions? Yes.
So if you spin up container for every test, it will probably cost more resources. So is there a way to avoid that? Or?
Yeah. We can use a lot of different design patterns. One I use for testing is called base test. So in a base test, which is a base test, or it's a base class, I can just instantiate there the container, and in every test class I can extend base test, and I can use features like before test for JUnit, and before we run all the tests, I spin up the container, run all the tests, and after I can go there and just stop the container. But we need to create this, that's super easy, like few lines of code, but every test class must extend this base test for that. Thank you for the question.
Maybe one question.
Go ahead.
Okay, so do you run the tests on the Eclipse CI or on something else?
In the?
On the Eclipse CI, like every Eclipse project gets like CI to the Eclipse.
Oh yes, we do have both. So we do have GitHub Actions that's run with container, and with Eclipse.io we are testing right now. So we create a job to make it work. Right now it's not working properly, but the idea is to make it work in both, in GitHub Action and also in the Jenkins of the Eclipse Foundation.
Yeah, so I was just curious if these test container things, if they were compatible with Eclipse Jenkins.
Yeah, they are, like the test containers itself, as it is inside the code, it will be. It will be managed inside the code, so the CI/CD, if it's not blocking the connection through to pull the Docker image, it will work for sure. Like in Jenkins, I know for sure because I'm using Jenkins and GitHub Actions. It's working perfectly.
The unique requirement to that test container is that the machine that will run has Docker, for example. So that is it.
Nice. Yeah, go ahead.
So you show an image when you mentioned the case that they were not testing, but it was just a line saying you're not considering this equals null. So
The coverage,
do you
yeah.
have a way to provide the patch or to provide the code?
If the tool will provide the code for you for that?
So like this is the test you're missing.
No. it will tell you, okay, I have this condition that I tried, like I don't know, the conditional was changed, but it won't tell you we need to create this test for that. It will tell you you missed this condition, but it needs to figure out, okay, this condition.
So it's like a warning.
It's like a warning. Yeah, it's more like warnings and tell you, okay, I did this condition, it failed. Now the implementation is up to you.
And are you considering adding a feature like that?
Don't know, to be honest. We really don't know because we are showing like super small part of the project. This PyTest is huge. You have conditions for everything. And I believe that it would be awesome to have a feature like this because, like, okay, you are trying to do this, it failed. This is the piece of code you could use, and it's up to us, like, to adopt that or not or change, right? So it would be nice, but unfortunately we don't have.
Is it possible to have different test containers? For example, we have some M1 or Intel and some
Yeah.
are running on one of the other.
You can specify in test containers the architecture and everything that you need from Docker. Basically, you can configure through test containers.
You can run
the
with
code.
Docker Compose, for example, if you have multiples. For example, Jakarta EE, I need to run my Java server with my database and something else, like, for example, Cassandra, I need to test with at least 3 instances, right? So I can make it possible.
The takeaways for this talk. Guidelines are super important because you guys will add consistency to your projects. Even private projects where you're working, not open source projects, test guidelines are super important. Second, modernization won't take that much time. And actually, if we start to modernize this and use the, like, say, the good tools for the job, it will decrease the amount of code we are in the maintenance. One thing to mention, if you guys are, for example, you guys are using JUnit 4 and you guys need to migrate to JUnit 5, it's a lot of code change or find and replace. But there's a tool called Open Rewrite that has a lot of formulas. And they have formulas like migrate from JUnit 4 to 5. This tool will do the job. We'll do the find, replace, and everything, and replace by the proper method signatures, packages, etc. Proper tools will help you to be faster and assertive. And don't fully rely on tools in general. Know what you're doing, but pass the responsibility to the tools as well, like the PyTest, like the coverage. They are sending us warning. So, but it's my responsibility to know what I should do. Cool?
Yeah.
Cool. So for later, for references, and for now, guys, thank you so much for your time, for your attention, for your questions. The slides are already in our Twitter, so you guys can go there, follow us, and access the slides. And thank you so much.